So guys, in our previous video, we saw certain examples of positively charged colloid and a negatively charged colloid. And as a sort of explanation, we also say that it is mainly with respect to the preferential adsorption of the ions, from the dispersion medium part, which is present in an excess quantity and which is also common ion to that of your lattice. But now the question arises that whatever the positively charged colloid and negatively charged colloid we are talking about, how can we determine it experimentally? In simple words, how can we make ourselves 100% sure that whatever the charge we are assigning to the colloidal particle is correct? So in order to have a better understanding and also a 100% assurance of the charge on the colloidal particle, we are going to see an experimental demonstration to determine the charge on the colloidal particle under the concept of electrophoresis. Electrophoresis. So basically, what do you mean by this electrophoresis? Let us understand. Remember, it is the movement of the colloidal particles. What it is? It is the movement of colloidal particles. How we are going to move these colloidal particles? Under an applied electric potential. Under an applied electric potential. Yes. So this process is called as what? Electrophoresis. So this is called as what? Electrophoresis. So what we are doing over here is basically, remember, so electrophoresis means what? It is the movement of what? Colloidal particles. Very much important. So it is the movement of the colloidal particles under an applied electric potential. So this process will be called as what? Your electrophoresis. Now the question arises, okay, so you have said that under the influence of an electric field, colloidal particle moves. But now the question arises, how can we say that by using the electrophoresis, our colloidal particle is having a positive or a negative charge? Do remember, whenever we are using an electric potential, of course we need two electrodes. Yes, a cathode, which is what? A negatively charged electrode. Alva. Similarly, an anode, which will be what? A positively charged electrode. So now what we are going to see is, of course, in our colloidal solution, if it is having a positive charged colloidal particles, of course it is going to migrate towards your negatively charged electrode. If your colloidal particles are positively charged, so it will go and form a coagulation or a precipitate near your negatively charged colloid. Whereas in case if your colloidal particle is a negatively charged colloid, of course where does it will go? It will be going towards the anode, towards that of your positively charged electrode. So depending upon the migration of your colloidal particles and where does they go and accumulate to the respective electrodes, we will be able to say that what type of a charge your colloidal particles are having experimentally. Now let us see how we will be going to do it. Basically, it is like your U-limb. Yes, it is like a U-limb. Yes, and this way. And here is your reservoir. Your stopcock. Yes. So basically, in this U-limb, we are making a use of our platinum electrodes. Two platinum electrodes. I'm just showing my platinum electrodes in this way. Of course, one terminal will be called as your cathode, since it will be connected to that of your negative terminal of the battery, and another will be that of your positive, which will be called as your anode. So through this reservoir, what you're going to put? Your colloidal solution. So through the reservoir we are putting our colloidal solution. So once you put, what happens, of course a balance will be obtained in both the limbs. So this will be filled up with your colloidal solution. So now on applying your electric field, what we are doing now, after filling the colloidal solution in your U limb, what we are doing, through the reservoir we have filled it. Now we are applying our electric field. Let us consider that our colloidal particle was a positively charged. Just for a mere explanation I am giving. Of course, before the experiment we will be knowing theoretically. But in order to make you understand over here, I am just taking, let it be by colloidal particle, but it will be a positively charged colloid. So what happens, since it is positively charged colloid, where it should go, of course, the colloidal particles will move towards that of your cathode. Alva? Because why? Positive kade hokagala, because anode will be going to repel it. Whereas the medium, whatever the colloidal particles they will be forming, they will go and form an aggregate agbidutte nimma cathode. So cathodal aggregate agi precipitate form agbidutte. Alle hogi they will be got stuck off. So now what you are going to do, how can we say it has been stuck off, is also important. Initially let us measure your measurements of your anode and cathode, the weight. Then after that of your experiment, once again you measure. Of course, in any one of the electrode the mass should have been increased. So that will come to know that accumulation has taken place. There is a one criteria. So depending upon the charge on the colloidal particles, of course they will try to migrate to their oppositely charged electrode under the influence of electric field. Such migration of the colloidal particles under the influence of electric field itself is called as what? Electrophoresis. Very much important concept. So this electrophoresis, we can say in simple words, is an experimental demonstration and also a 100% assurance in order to determine what charge our colloidal particles are having. And remember, whenever we are talking about the charge, it is with respect to the fixed layer of your colloidal particles, okay, which has been formed surrounding your colloidal particles through the preferential adsorption of your ions. So this was with respect to the electrophoresis. But another method was also introduced. What did we do is, basically here we are saying that there is a movement of the colloidal particles. Now the scientists scratch their head. Is there a possibility to move your colloidal medium particles, or we can say dispersion medium particles? Alva, dispersion medium particles. Namage gottu, ಒಂದು colloid ಅಂದ್ರೆ ಅಲ್ಲಿ ಎರಡು phases ಉಂಟು, ಒಂದು dispersed phase, ಒಂದು dispersion medium. Electrophoresis mein what is happening? There is a movement of your colloidal particle. Now when the scientists thought, is there any possibility to move your dispersion medium particles, they came to a conclusion, yes, we can do it. So that was studied under the concept of your electro-osmosis. So what does this electro-osmosis say? Basically a very important concept one has to know. So basically in an electrophoresis, by some means, by any means, okay, by some means, if we are going to obstruct the path or obstruct the movement of the colloidal particles, once again I am repeating, so in an electrophoresis, by some means, if we are going to stop the movement of the colloidal particles in the presence of electric field, in that case there will be the movement of your dispersion medium particles. Able to understand? ಯಾವುದೋ ಒಂದು ಮೀನ್ಸ್ ಇಂದ ನಾ ಏನ್ ಮಾಡ್ತೀನಿ, ಅಫ್ಕೋರ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ ಇದೇ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ, ನಥಿಂಗ್ ಐ ಆಮ್ ಚೇಂಜಿಂಗ್. ಬಟ್ ಯಾವುದೋ ಒಂದು ಮೆಥಡ್ ಇಂದ ಏನ್ ಮಾಡ್ತೀನಿ, ಐ ಆಮ್ ಅಬ್ಸ್ಟ್ರಕ್ಟಿಂಗ್ ದಿ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ಯೋರ್ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್, ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇನ ಮೂವ್ಮೆಂಟ್ ನ ನಾನು ಅಬ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡ್ತೀನಿ, ಸ್ಟಾಪ್ ಮಾಡ್ತೀನಿ. ಆದ್ರೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತೂ ಕೊಡ್ತಾನೆ ಇದ್ದೀನಿ. ಸೊ ಆ ಒಂದು ಮೂಮೆಂಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಿಮ್ಮ ಡಿಸ್ಪರ್ಸ್ ಫೇಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸ್ಟಾಪ್ ಮಾಡಿದ್ವಲ್ಲ, ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, your dispersion medium particles try to migrate towards the electrode. So that phenomenon will be called as what? Your electro-osmosis. Yes. So how can we say electro-osmosis? How can we define this? So when electrophoresis, alva, that is what movement of the colloidal particles in the, what you can say, in the under the influence of electric field, alva. So when electrophoresis is obstructed by some suitable means, yes, it is observed what? The dispersion medium begins to move. Under what? Under in an electric field, or under the influence of an electric field, So this phenomenon will be called as what? Your electro-osmosis. Very much important. So when electrophoresis is obstructed by some means, okay, if you are going to block your electrophoresis, so at that moment what happens? Under the influence of electric field, remember electric field irlebeku. Under the influence of electric field, your dispersion medium begins to move. And that phenomenon is called as what? Your electro-osmosis. Very much important thing. So what we have learned today, remember, of course we came to know that whenever we are talking about a colloidal system, each and every colloid in a system will be having the same charge associated with it. It could be positive or it could be negative. So depending upon what type of a charge a fixed layer is having, we are able to distinguish it as a positively charged colloidal sol or a negatively charged colloidal sol. And we also saw certain examples. But in order to make 100% assurance through experimental criteria, we selected a method which is called as what? Electrophoresis. Which says what? So when you are applying an electric field by utilizing the 2 platinum electrodes in a U-limb, there will be the movement of the colloidal particles under the influence of electric field. So that a movement of a colloidal particle under an applied electric potential is called as what? Your electrophoresis. So ಯಾವ ತರ ಇದು ನಮಗೆ ಈಗ 100% assurance ಕೊಡುತ್ತೆ? In case if your colloid is a positively charged colloid, it will be going and forming a precipitate at a cathode, being a negatively charged electrode. Similarly, if your colloidal particle is a negatively charged, of course it is going to move towards the anode and forms a precipitate over there. So depending upon where does your colloidal particles goes and form a precipitate, on which electrode it is going to precipitate, depending on that part or that criteria, we will be able to say that what charge your colloidal particle has. On its fixed layer. Very much important concept which gives us 100% assurance to talk about the charge on the colloidal particle. But now when the question arises that is there any means to stop your colloidal particles movement under the influence of electric field, of course there is some certain means. So at that period of time what happens? So in case by any means if you are blocking the movement of the colloidal particles under the influence of electric field, what happens? Your dispersion medium particles will try to move under the influence of electric field. So the movement of the dispersion medium particles under the influence of electric field when by obstructing your electrophoresis by some suitable means, the phenomenon will be called as what? Your electro-osmosis. So do remember, in case if electro-osmosis has to be conducted, means first we have to block your electrophoresis. Then only it will be taking place your dispersion medium particles to move towards your respective electrodes under the influence of electric field. So such a phenomenon will be called as your electro-osmosis. Is that clear? So next we are going to see that, of course, whenever we are talking about the charge on the colloids, of course we came to know that your colloidal particles, because of having the same charge, they are always in a continuous random motion. They are always moving. And that was itself was the main factor which was able to say the stability of the colloid because of its continuous random kinetic motion of the colloidal particles. Now in our next video or in next part we are going to see that what are the methods in order to coagulate. What is that? In order to coagulate our lyophobic salts. Coagulate our lyophobic salts. Coagulate ಅಂದ್ರೆ ಅರ್ಥ ಏನು ಇಲ್ಲ, how to make it as a precipitate. Precipitate ಅರ್ಥ ಏನು, ಈ ಒಂದು ಕೊಲಾಯ್ಡಲ್ ಸಿಸ್ಟಮ್ ಇತ್ತು, ಎಲ್ಲ ಕೊಲಾಯ್ಡ್ಸ್ ಇತ್ತು, ಡೈಮೆನ್ಷನ್ಸ್ 1 ನ್ಯಾನೋಮೀಟರ್ ಇಂದ 1000 ನ್ಯಾನೋಮೀಟರ್ ಇತ್ತು. ಈಗ ನಾವು ಕೆಲ ಮೆಥಡ್ಸ್ ನೋಡ್ತೀವಿ. ಯಾವ ತರ ಅಂದ್ರೆ, ಈ ಕೊಲಾಯ್ಡಲ್ ಪ್ರತಿಯೊಂದು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ ಹತ್ರ ಬಂದು ಒಂದು ದೊಡ್ಡ ಮಾಲಿಕ್ಯೂಲ್ ಫಾರ್ಮ್ ಆಗಿ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಿ ಬಾಟಮ್ ಅಲ್ಲಿ ಕೂತ್ ಬಿಡುತ್ತೆ. They will not move. Instead, they will come and precipitate at the bottom. So that process is called as a coagulation. So how to proceed with that coagulation will be seen in this video by certain steps or by certain methods. Is that okay? So guys, now let us see how to coagulate our colloidal particles. Remember, in order to coagulate, only one important criteria we have to do. Whatever method we are going to do, all will be having the same principle. What is that principle? Of course, whatever the stability of the colloidal particle, or in simple words, whatever the reason for the movement of the colloidal particle is due to the presence of the charge on the colloidal particles. So now we are going to see certain methods that how can we remove that charge. So on removing the charge, what happens? Your colloidal particles come together, they will be forming a bigger size particle and they are going to settle at the bottom. So one thing should get printed in your brain, that whatever the methods we are writing or we are going to study in the coagulation of your lyophobic salts, it all depends just one principle, that is removing of the fixed layer of your colloidal salt. So let's first of all understand, as we have done now itself, the first method is by your electrophoresis. By your electrophoresis. Of course, here itself we have seen it. What is happening? Whatever the charge which was present on the colloidal particles, due to the presence of it, what is happening? Each and every colloidal particles will come and they get coagulated at their respective electrodes. That is oppositely charged. So what happens? Mutual neutralization takes place. Alva? Ilena untu, for example, na tagondide adu positively charged to colloid. Positive charge ittu. So when they are migrating towards the cathode, which is a negative charge, what happens? Plus and minus became neutralized. Since the colloidal particles are moving towards their oppositely charged electrodes, they get discharged. Alva, in charge irutte, they will lose that charge and they got form coagulate ಆಗ್ತದೆ. So can just see ಆ ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಮೇಲೆ ಏನಾಯ್ತು, ಪ್ರತಿ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಬಂದು ಕೂತು ದೊಡ್ಡ ಪಾರ್ಟಿಕಲ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಉಂಟು. So once they form in this way, that itself will be called as what? Your coagulation. So electrophoresis is a method, we can say. One advantage we are able to see, that we are able to determine the charge. And another important thing was, what about electrophoresis is, it is also a method of coagulation. So where your colloidal particles are getting discharged and they are getting precipitated. The second most important thing is your by mixing two oppositely charged salts. Two oppositely charged salts. ಅಲ್ವಾ? ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸಾಲ್ ನ ತಗೊಂಡು ಅದನ್ನ ನಾವು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಸಾಲ್ ಜೊತೆ ಹಾಕಿದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಮ್ಯೂಚುವಲ್ ಕೋಆಗುಲೇಷನ್ ಹಾಗೆ ಆಗುತ್ತೆ, ನ್ಯೂಟ್ರಲೈಸ್ ಆಗುತ್ತೆ, ಎಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒಟ್ಟು ಬರುತ್ತೆ, ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ದೊಡ್ಡ ಆಗುತ್ತೆ, ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಏನಾಗುತ್ತೆ? when oppositely charged salts are mixed together. Oppositely charged salts are mixed in equal proportions. Very much important alva. ಎರಡು equal proportional ಇರಬೇಕು. ಒಂದು ಪ್ಲಸ್ ಜಾಸ್ತಿ ಆಗಿಬಿಟ್ರೆ ವಾಪಸ್ ಅದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಸೊ ಏನಾಗುತ್ತೆ? You have to mix the two negative as well as a positive charge salts in a equal proportion. So mixing of an oppositely charged salts in an equal proportion, what they will do? They will neutralize the charge. They will neutralize the charges and gets precipitated. Neutralize the charges and get precipitated. Alva? So now elli hodru kuda ಎರಡು ಮೆಥಡ್ ನಾವು ಏನು ಕಲ್ತ್ವಿ? Electrophoresis by mixing of two oppositely charged salts. ಇವೆಲ್ಲರನ್ನ ನಾವು ಏನು ನೋಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ, basically we are mainly concentrating about the charge on the colloidal particles. ಅಲ್ವಾ? ಸೊ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರೋಫೋರೆಸಿಸ್ ಅಲ್ಲಿ ಕೂಡ ನಾವು ಚಾರ್ಜ್ ನ ಹೇಗೆ ನೋಡಿದ್ವಿ, ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡ್ತಿದೀವಿ. ಸೆಕೆಂಡ್ಲಿ ಕೂಡ ನಾವೇನ್ ನೋಡ್ತಾ ಇದೀವಿ, ಯಾವ ತರ ನಾವು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡ್ತಿದೀವಿ. ಒಂದು ಪಾಸಿಟಿವ್ ಕಂಟೆಂಟ್ ನ ತಗೊಂಡ್ರೆ ಸಾಲ್ವ್ ನ ತಗೊಂಡು ಅದನ್ನ ನಾವು ನೆಗೆಟಿವ್ ಸಾಲ್ವ್ ಜೊತೆ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ಲಿ ಅಫ್ಕೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ಪ್ಲಸ್ ಮೈನಸ್ ನ್ಯೂಟ್ರಲೈಸ್ ಆಗಿ ಪ್ರೆಸಿಪಿಟೇಟ್ ಸಿಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಲೆಟ್ ಮಿ ಗೋ ವಿತ್ ಅನ್ ಹೈಡ್ರೇಟೆಡ್ ಫೆರಿಕ್ ಆಕ್ಸೈಡ್ ಅಲ್ವಾ, ವಿಚ್ ಇಸ್ ಅ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ಡ್ ಸಾಲ್ಟ್. ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ಮಿಕ್ಸ್ಡ್ ವಿತ್ ಅನ್ ಆರ್ಸೆನಿಕ್ ಸಲ್ಫೈಡ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿ ಅ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ಡ್ ಸಾಲ್ಟ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಮ್ಯೂಚುವಲ್ ಕೋಆಗುಲೇಷನ್ ಆಗಿ ಏನಾಗುತ್ತೆ, ಇವು ಎರಡು ಸಾಲು ಒಟ್ಟಿಗೆ ಬಂದು ಒಂದು ದೊಡ್ಡ ಪಾರ್ಟಿಕಲ್ ಸಿಗುತ್ತೆ. ಪಾಸಿಟಿವ್ ಇದ್ದಾಗ ಇದು ಕೊಲಾಯ್ಡ್, ನೆಗೆಟಿವ್ ಇದ್ದಾಗ ಇದು ಕೊಲಾಯ್ಡ್, ಯೂನಿಕ್ ಆಗಿರುತ್ತೆ. ಆದ್ರೆ ಪ್ಲಸ್ ಮೈನಸ್ ಒಟ್ಟಾದಾಗ ಏನಾಗುತ್ತೆ, ಹೈಯರ್ ಡೈಮೆನ್ಷನ್ ಪಾರ್ಟಿಕಲ್ ಸಿಗುತ್ತೆ, ವಿಚ್ ವಿಲ್ ಬಿ ಮೋರ್ ದನ್ ದಟ್ ಆಫ್ ಯೋರ್ 1000 ನ್ಯಾನೋಮೀಟರ್. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸಸ್ಪೆನ್ಷನ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸಸ್ಪೆನ್ಷನ್ ನೋಡಿದ್ವಿ ಅಲ್ವಾ, ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ದೊಡ್ಡ ಆದ್ಕೂಡ ಏನಾಗುತ್ತೆ, ಕೆಳಗಡೆ ಬಂದು ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಿ ಫಾರ್ಮ್ ಆಗ್ಬಿಡುತ್ತೆ. ದೇ ವಿಲ್ ಬಿ ನಾಟ್ ಬಿ ಮೂವಿಂಗ್, ಇನ್ಸ್ಟೆಡ್ ದೇ ವಿಲ್ ಬಿ ಫಾರ್ಮಿಂಗ್ ಅ precipitate. So this is what we are doing in your, when it is mixed of your two oppositely charged salts in an equal proportion. Next important method is called as your by boiling. Very much important. By boiling. ಬಾಯ್ಲ್ ಮಾಡಿದಾಗ ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. ರಿಮೆಂಬರ್, ಸೊ ಯಾವಾಗ ನೀವು ಒಂದು ಸಾಲ್ ನ ಬಾಯ್ಲ್ ಮಾಡ್ತೀರಾ, ವೆನ್ ಯು ಆರ್ ಬಾಯ್ಲಿಂಗ್ ಯೋರ್ ಸಾಲ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್, whatever the adsorbed layer is there of your colloidal particle, it gets disturbed. How it is getting disturbed, let us see. So what happens on boiling, your colloidal particle and that of your colloidal medium particles, they are going to colloid with each other. So there will be increase in the collision between your colloidal particle and that of the dispersion medium particles. Due to the increased collision, what happens? Yes, whatever the charge which is present on the colloidal particles, they get reduced. So ಏನಾಗುತ್ತೆ, ಮ್ಯೂಚುವಲ್ ಕೊಲ್ಯೂಷನ್ ಆಗ ಕಾರಣದಿಂದ ವಾಟ್ ಎವರ್ ದಿ ಫಿಕ್ಸ್ಡ್ ಲೇಯರ್ ಏನಿರುತ್ತಲ್ವಾ ನಿಮ್ಮ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಮತ್ತೆ ಡಿಸ್ಪರ್ಷನ್ ಫೇಸ್ ಮಧ್ಯದಲ್ಲಿ, ಅದೇನಾಗುತ್ತಾ ಹೋಗುತ್ತೆ, ರೆಡ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಆ ಒಂದು ಕೊಲ್ಯೂಷನ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ, ವಾಟ್ ಎವರ್ ದಿ ಚಾರ್ಜ್ ವಿಚ್ ವಿಲ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಆನ್ ಯೋರ್ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್, ದೇ ಗೋ ಆನ್ ಡಿಕ್ರೀಸಸ್. So once the charge is getting reduced, what happens? Of course, the colloidal particles will come together and they will be forming a larger particle and they get settle at the bottom. Or in simple words, they get precipitate. So on boiling, your adsorbed layer is getting disturbed. How it is getting disturbed? By the mutual collision of your colloidal particles and your dispersion medium particles. So that collision, what does it do? It reduces the charge on the colloidal particles. And when such a charge is getting reduced, what happens? Your colloidal particles are getting precipitated. But the most important thing, and another method we are going to see, and also we have seen it in our purification of the colloid. But here we are going to see that by utilizing that purification technique, how can we coagulate? Which is called as by persistent dialysis. Persistent ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ, by longer time dialysis ಅಂತ simple words ಹೇಳಬೇಕು ಅಂದ್ರೆ. So when I was doing the dialysis part, I have mentioned you that what, so dialysis is an option of the method where we are utilizing it in order to remove the excess of electrolyte ಅಲ್ವಾ. ಅಫ್ಕೋರ್ಸ್ ಅವತ್ತೇ ಹೇಳಿದ್ದೆ ನಾನು, ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಒಂದು ಸ್ವಲ್ಪ ಕ್ವಾಂಟಿಟಿ ಇರಲೇಬೇಕು ಅಲ್ವಾ. ಯಾಕೆ, ಆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನಮಗೆ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಹಂಗೆ ಆಕ್ಟ್ ಆಗಿ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಲೇಯರ್ ಕೊಡ್ತಾ ಉಂಟು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಗೆ. ಸೊ ಆ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಲೇಯರ್ ನಮ್ಮ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ದಿ ಕೊಲಾಯ್ಡಿಗೆ ಇಂಪಾರ್ಟೆಂಟ್. ಆರ್ ಇನ್ ಸಿಂಪಲ್ ವರ್ಡ್ಸ್, ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಅ ಮೀನ್ಸ್ ಆಫ್ stability for the colloidal particles. But that should be present in a very trace quantity. Then why did we choose a dialysis in our purification method? In order to remove certain excess of electrolytes. ಅಲ್ವಾ. ಸೊ ಇಲ್ಲೇನಾಗ್ತಂತು, ಪರ್ಸಿಸ್ಟೆಂಟ್ ಡಯಾಲಿಸಿಸ್ ಮಾಡಿದಾಗ, ಲಾಂಗ್ ಟೈಮ್ ಡಯಾಲಿಸಿಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ವಾಟ್ ಎವರ್ ದಿ ಟ್ರೇಸ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಯುವರ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಏನಿರುತ್ತಲ್ವಾ, ಟ್ರೇಸ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್, ದಟ್ ವಿಲ್ ಬಿ ಆಲ್ಸೋ ಗೆಟ್ ರಿಮೂವ್ಡ್. ತುಂಬಾನೇ ಜಾಸ್ತಿ ಹೊತ್ತು ತನಕ ಡಯಾಲಿಸಿಸ್ ಮಾಡ್ತಾ ಹೋದಂಗೂ ಏನಾಗುತ್ತೆ, ಯಾವ ಟ್ರೇಸ್ ಕ್ವಾಂಟಿಟಿ ವಿಚ್ ವಾಸ್ ಅ ಸೋಲ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ದ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ದಿ ಕೊಲಾಯ್ಡ್, that will be also get removed. Trace quantity of your electrolyte also gets removed. So when such electrolyte itself is missing, the colloidal particles will not have any option for the preferential adsorption of the ions. So our colloidal particles, what happens? They will be not having any fixed layer. So each colloidal particles come together and they form a precipitate at the bottom. So by this way also we can coagulate your lyophobic salts. Able to understand? So on prolonged dialysis, persistent, in other words, is a prolonged dialysis. What happens is basically we are removing the trace quantities of electrolyte. Complete ಆಗಿ remove ಮಾಡ್ಬಿಡ್ತೀವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, colloids will become unstable. ಯಾವ ತರ ಯಾಕೆ ಹೇಳೋದು ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? Because whatever the electrolyte which we were using, that was acting as what? Your dispersion medium. It was instant giving you a charge on the colloidal particles. When such electrolyte itself has been removed, what happens? Your colloidal particles is not having any means for a preferential adsorption of ions. When the colloidal particle itself is not having any ions, of course they will not undergo repulsion. So when they are not undergoing repulsion, what happens? Each colloidal particles will come together, they will form a larger, bigger size particle and they get precipitated. So this is also an important method of coagulation. Remember, coagulation of your lyophobic salts. Most important part, of course, we are going to read this concept once again by certain theoretical aspects. Okay, so very much important. Another method which is called as by addition of your electrolytes. By addition of your electrolytes. Of course, electrolytes, trace quantity of electrolytes is very much important for the stability of the colloid. But now when the question arises, even when I was mentioning my purification, I mentioned that excess of electrolyte has to be removed. And as a reason I said what over there? Because excess of electrolyte causes coagulation. Now we are going to see that how this excess of electrolytes are causing an coagulation. Remember, electrolyte means it will be having both your positive as well as a negative charge. So no problem with that. But what happens whenever such excess is present? What happens? Excess of your positive will be also there, negative is also there. ಸೊ ಒಂದ್ಸರಿ ಏನಾಗುತ್ತೆ, ಒಂದು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ ಪಾಸಿಟಿವ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳುತ್ತೆ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಲೇಯರ್ ನ ತಗೊಂಡು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇಂದ. ಆದ್ರೆ ಏನಾಯ್ತು, ಈಗ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ನೆಗೆಟಿವ್ ಕೂಡ ಉಂಟು, ಅದೇನಾಗ್ಬಿಡುತ್ತೆ ಈಗ ಮ್ಯೂಚುವಲ್ ಆಗಿ ನ್ಯೂಟ್ರಲೈಸ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಎಕ್ಸೆಸ್ ಆಗಿದ್ದು ಬಿಟ್ರೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನಾಗುತ್ತೆ, ವೆನೆವರ್ ವಿ ಆರ್ ಚೂಸಿಂಗ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇನ್ ಅನ್ ಎಕ್ಸೆಸ್ or whenever we are putting the electrolyte in an excess, what happens, it also coagulate the colloidal particles. ಯಾವ ತರ coagulate ಆಗ್ತಾ ಉಂಟು, whatever your charge is present on the colloids, they are going to interact with the ions of your opposite charge. And of course, when they are interacting with the opposite charge, what happens? Neutralization takes place, and that will be leading to that of your mutual coagulation. Remember, that is the reason excess of electrolyte is a impurity when we are discussing with respect to that of your purification of the colloid. So whenever an excess of the electrolyte is there, what happens? Coagulation takes place. Why? Because whatever the ions which is present on the colloidal particles, they are going to interact with that of your oppositely charged of your electrolyte, and mutual coagulation takes place. Remember, so whatever the electrolyte we are going to add, okay, whatever the electrolyte we are going to add in order to cause the coagulation, remember, such an electrolyte is called as coagulating ion, or it is also called as what? Fluctuating ion. It is also called as fluctuating ion. Very much important. Flocculation, coagulation, precipitation, important terms ಇವೆಲ್ಲ ನೆನಪಿಟ್ಕೊಂಡಿರಬೇಕು. ಏನ್ ಹೇಳ್ತಾ ಉಂಟು, whatever the electrolyte we are adding in order to cause the coagulation, ಅಲ್ವಾ? So the ion responsible for neutralization of the charge on the particle, the ion responsible for the neutralization of the charge on your colloidal particle is called as what? Coagulating ion, or also it is also called as a fluctuating ion. 1 marks chances are there. What do you mean by fluctuating ion, or what do you mean by coagulating ion? So the ion which is responsible for the neutralization of the charge on the colloidal particle, okay, so it is called as a coagulating ion or a fluctuating ion. Why did I mention it is an important? Because we are going to see in our next video, in case if you are having 3 electrolytes, that is we will be saying as an aluminium trichloride, your barium sulfate or barium chloride, I can just take it as a barium chloride, and that of your sodium chloride. And now you have been given with that of your colloidal particles. Now the question arises, of course all the 3 are the electrolytes itself, but now the question arises, which electrolyte can cause the coagulation at a faster rate? I'm repeating my question. You are having the three electrolytes: aluminium trichloride, barium chloride, sodium chloride. All the three are electrolytes. And you have been given with a colloidal system. And your task is you have to coagulate it. But the major important task, one more criteria is, you have to coagulate your colloidal system at a faster rate. Now the question arises that among these three electrolytes, which will be having the higher tendency? Which will be having the higher tendency to coagulate your coagulating system or your colloidal system at a faster rate? So that is going to be studied under the concept of Hardy-Schulze rule. Hardy-Schulze rule, which is going to say, or which is going to give us a hint, or we are able to say an important statement in order to determine which electrolyte has the greater power to cause the precipitation. I repeat, so according to this rule, we are going to say that which electrolyte can have the greater tendency to coagulation or that of your precipitation, which will be seen in your next video. So in our today's video, we have seen the concepts of electrophoresis and electro-osmosis. So electrophoresis means it is the movement of your colloidal particles, under the influence of an electric field. Whereas an electro-osmosis, in by certain means, if we are going to stop the movement of the colloidal particles, our dispersion medium particles will be moving under the influence of electric field. So that phenomenon is called as an electro-osmosis. We also have seen an important methods in order to coagulate our lyophobic salts. And the major methods, whatever we have seen, all are including one important concept, that is in order to remove the fixed layer of our colloidal particles, because it is the one which is giving the stability for the colloids. In case if we are removing the fixed layer, what happens? Colloidal particles will not undergo repulsion. Each and every colloidal particles will come together. They will be forming a bigger size particle greater than that of 1000 nanometer, and as a suspension they will be getting precipitated. So that process is called as a coagulation. And we have seen certain methods, and one important method, it was your electrophoresis itself, where it is causing your colloidal particles to get discharged when they are coming at the respective electrodes under the influence of electric field. We also saw by mixing of two oppositely charged salts, that is, one is your in an equal proportion. When we also saw an example of your hydrated ferric oxide when it is mixed with that of your arsenic sulfide, mutual neutralization takes place. You will be getting your coagulation part. Similarly, we also saw your boiling method. When we are boiling, what is happening? It increases the collision between that of your dispersed phase particles and the dispersion medium particles, which in turn reduces the whatever the charge on your dispersed phase particles, and it will be leading to that of your mutual coagulation. Similarly, by your persistent dialysis, remember, I'm not just writing dialysis, by persistent dialysis, that is by prolonged dialysis, at a longer duration I'm carrying out my dialysis. So at that moment, what happens? Whatever the trace amount of electrolyte which was present in your colloidal system, that will be also gets removed, which in turn makes your colloidal system or colloidal particles unstable, and it will be causing your coagulation. Similarly, the next important part was the addition of electrolytes. So when you are adding the electrolytes in an excess amount, what happens? The mutual neutralization takes place, alva. So when such neutralization takes place, of course, we are seeing your coagulation. Now I want to just mention an important part which I didn't mention you in my earlier video because it was confuse you. But now I'd like to mention, remember guys, your hemoglobin, remember your hemoglobin is an example of a positively charged salt. Positively charged salt, very much important, okay? Whereas that of your blood is a negatively charged salt. Very much important concept. Many competitive exams they have been asked. Hemoglobin content enuntala, blood dalira hemoglobin content enuntala, that is an example of a positively charged salt. Whereas when we are considering the blood over here, just the blood, it is a negatively charged salt. यहाँ के blood is a negatively charged and because it is due to the presence of a carboxyl group, COO minus group ಏನು ಉಂಟಲ್ವಾ ಯಾವ್ದ್ರದಿಂದ of your sialic acid ಅಂತ ಬರುತ್ತೆ RBC ಮೇಲೆ ಇರುತ್ತೆ red blood cells ಮೇಲೆ sialic acid. So due to this carboxyl group of a sialic acid is making your blood as a negatively charged salt, whereas your hemoglobin, of course, the ferric content, it is having a positively charged salt. An important concept I would just like to mention. Now, in case if certain cases I got a doubt, I don't know about you. So in our body we are having both hemoglobin unto blood untu. One method of the coagulation nodidvi enanta by mixing two oppositely charged salts in an equal proportion coagulate ಆಗಬೇಕಿತ್ತು. But of course, ನಮ್ಮ blood coagulate ಆಗ್ತಾ ಇಲ್ಲ. Coagulate ಆಗಿದ್ರೆ of course we are all going to die. But our part of the blood is not getting to get coagulated. Why I am saying so? Because your hemoglobin is a positively charged salt and that of your blood is a negatively charged salt. Remember, our body is a God's gift. ಯಾಕೆ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ even though we are having the two oppositely charged salts in an equal proportion, our body has developed an anticoagulating agent, which is called as what? Heparin. So this heparin acts as an anticoagulant agent. So this is not allowing our hemoglobin and blood to get coagulated. That is the reason in our body there is an easy flow of your blood and that of your hemoglobin without any coagulation or precipitation. In case if this heparin was not there, you can only assume the situation of our body. Everyone will be a dead body. Alva? So remember, why did I mention this? Because your hemoglobin is an example of a positively charged salt, whereas our blood is an example of a negatively charged salt. This negative elinda vartantu by the carboxyl group of your sialic acid. So certain competitive exam in your books also many times they are written as an hemoglobin, and within the bracket they have also given as blood. So basically this is not a correct way of writing, because hemoglobin is what? It is a positively charged salt. Blood is a negatively charged salt. I have also mentioned the same thing in my video because I don't want to confuse you at that particular moment, because we were studying with respect to that of your types. But when we have learned now what do you mean by coagulation, I thought it would be important to now itself to make you sure that whatever in our body we are having the hemoglobin, it is a positively charged salt, whereas that of your blood is a negatively charged salt. So in case if you are writing an example for a positively charged salt, make sure you just write your hemoglobin. In case if you are writing the negative charged salt, make sure you just write your blood. And do mention, there is nothing wrong to mention, because it will make sure that whoever is correcting your paper, they will be thinking you are having a much knowledge. So the blood, whatever the negative charged salt is coming, it is by the carboxyl group of your sialic acid. Carboxyl group is COO minus alva. E negative charge that is giving you the negative charge on that of your blood. When the question arises that why they are not coagulating, it is because of the presence of an anticoagulant in our body, which is called as an heparin, which does not which we can say, which is not allowing your hemoglobin and blood to come together and aggregate. Able to understand? So these are also certain things which has to be kept in your mind. And remember, your hemoglobin and blood is also a colloidal particles itself. Okay. So in our next video, as I mentioned, we are going to see an important concept of your Hardy School's rule, which states us that how can we determine your usage of the electrolyte in order to increase the rate of your coagulation. Okay.